So now we're going to start to talk about something called complex numbers, which really aren't that different from what we did in the last lesson. It says all numbers fall into a very broad category known as complex numbers. Complex numbers can always be thought of as a combination of a real number with an imaginary number and will have this form. So basically, if we have something where we have a real number and an imaginary number, it's called complex because it has both parts. So A is the real part, and BI is the imaginary part. So if we have a real number, like, 10, that's actually in the subset of complex, or in the set of complex numbers, because it has a 0 I on it, so there is no I. So real numbers fit into the complex number system, but we don't really have to think about that up until now that we know about the imaginary numbers. So we're going to find each of the following sums and differences. So we're adding or subtracting two complex numbers. Now, when you're adding and subtracting, you don't get any powers of I, so things are pretty straightforward. And for all intents and purposes, the I kind of acts like an X. So I'm adding here. So you can think of the real parts as being like terms. So -2 plus 6 is 4. And then 7i plus 2i is 9i. And this is a plus bi form whenever I write the real part plus the imaginary part together. Now here we have subtraction. So if you remember, when we subtract a binomial, we have to distribute a -1. So this problem is 5 plus 3i minus 2 plus 7i, because we have -1 times -7. So basically those signs change. This is nothing new for imaginary or complex numbers. This is just the way subtracting binomials works. So 5 minus 2 is 3. 3i plus 7i is 10i. So if you want to pause and try the next one, you can, and then come back and check it. So here we do have another one where I want to distribute the -1. So I have -3 plus 5i plus 8. -1 times -8 is positive, minus 2i. So my real components I add is 5, and then 5i minus 2i is 3i.